So there's these conflicting equities involved with this. For this reason, FAA has started to roll out means to limit or shorten the amount of time and amount of space that the national airspace would be impacted. Pumping data directly from the launch operators into the FAA air traffic control system.
Hello, and welcome to the Space Policy Show. I'm Colleen Stover with the Aerospace Corporation. This installment of the six-part series about space safety is about space launch, and I'm excited to gather some international perspectives today. On the show, we have Rob Unverzagt, Principal Director of Civil and Commercial Launch Projects here at the Aerospace Corporation. And we've also got Nick Pearson, Manager of Safety and Regulatory Operations at Rocket Lab in Mahia, New Zealand. Thank you guys both very much for joining today.
Happy to be here.
Thanks for having us.
So Rob, I'm going to start with you. Could you just give us the 20-second elevator introduction? Who are you and why are you here today? Why did I ask you here?
Oh, that's a good question. I don't know. I run our civil and commercial launch organization. Most of our work at Aerospace Corporation is for the DoD or intelligence community, but we also have what we call civil and commercial customers, making up some slice of our business. And some slice of that involves launch. So my group is responsible for bringing to bear the launch expertise in the corporation for those other customers, such as NASA, FAA, and actually we do work for commercial companies themselves. So it's a very varied customer set that I have in my group.
Great, thank you. And I know you got your start in defense, the defense world. So I'm glad that you've moved into other realms as well. So Nick, how about you? Can you just quickly introduce yourself and your role there at Rocket Lab?
Absolutely. Thanks again for having me on, Colleen, and nice to meet you, Rob. So yes, Nick Pearson, Manager of Safety and Regulatory Operations, as you said, here at Rocket Lab, and I have the pleasure of working with a couple of amazing teams here, and we take care of everything from our occupational or environmental health and safety of our people, and then, as I suspect we will probably more touch on today, we have the regulatory or licensing team, if you like, which really deals with public safety for our launch and spacecraft operations. So diverse team, and I love working with them all.
Great, thank you. Thanks. And this is you are Rob. You're our first guest from New Zealand, so congratulations. We've had ones from Russia and from Europe, but not New Zealand. So.
Thank you. Thank you. I was told the other day that Mahia was the fourth most prolific launch location in the world. So US, China, Russia, and then the Mahia Peninsula in New Zealand. So there you go. We're making a name for ourselves.
That's very exciting. Well, so while we're on that, introduce us to Rocket Lab's launch facilities. There's the Mahia is the launch facility #1, and you've also got a second one, right? A third one.
Yeah, that's right. So down on the Mahia Peninsula, which is on the east coast of the North Island here in New Zealand, we have the only private orbital launch facility in the world, which is pretty exciting. And that was our OG, if you like, the original gangster of the launch facilities. I believe that was commissioned in 2016. Someone will jump in the comments and correct me if I'm wrong. And so we can fly a pretty wide range of inclinations out of there, about 30 to 100 degree inclinations from there. And there's a whole swathe of benefits to operating a private spaceport, if you like. And so that's fully licensed by FAA and the New Zealand Space Agency. And then, as you alluded to there, we also have Launch Complex 2 now, which has been operational for some time. And we fly out of the NASA Wallops Flight Facility, specifically the Virginia Spaceport, or Virginia Commercial Spaceport. And then soon to hit the books is LC3, which we'll be launching the new Neutron launch vehicle from. And that's also at Wallops, Virginia Commercial Spaceport.
Excellent. So have you ever had the pleasure of visiting Wallops in Virginia?
I have. I've been there a couple of times. We've got a really great team, and we obviously work really closely with those guys. So Good bunch of people out there.
Yeah, it's pretty cool. I'm actually in the Washington, D.C. area in Alexandria, and I have been able to see launches from Wallops if you run outside at the right time and look the right direction. It's really cool.
That is cool.
So, Rob, can you introduce our audience a little bit to some of the launch complexes in the States? I know, everyone knows the big one, Cape Canaveral.
Right.
There's also Vandenberg. There's
Right.
a couple of private ones. Can you just kind of give a little layout of the landscape for us?
Sure. As you mentioned, there's Cape Canaveral/Kennedy Space Center in Florida and Vandenberg here in California. And when I run outside, I can see launches from Vandenberg also. So that's always nice. But in addition, as Nick mentioned, there's Wallops up the coast in Virginia. Kodiak Spaceport in Alaska does launch small launch vehicles, generally to sun synchronous orbits. That's a very particular orbital regime that's very popular for Earth observation because the sun you keep the same shadows every time you go over. So that's very good for repetitive observations. There are actually, I believe, there are over 12, and I can't recall the exact number, FAA licensed spaceports in the US. Some of those are coincident with Cape Kennedy, Cape Canaveral, Vandenberg. Kodiak, as I mentioned, Cecil Field in Florida is another licensed spaceport. Oklahoma has a spaceport license. They haven't launched anything yet. New Mexico, Spaceport America, where the Virgin Galactic flies out of or anticipates flying out of. But there are other applicants coming in. You just see news releases about Maine would like to get a spaceport, and other places, which you might not think of as typical, spacefaring locations in the U.S. But FAA applies the same standards to everybody. There's the Code of Federal Regulations governs that, so they will have to meet the same safety rules as the other. Not only the federal spaceports, but all the other spaceports also.
Right. So, well, let's get on that about launch safety, since that's the topic of our conversation. And I'll stick with you, Rob, while I have you. So, what kinds of considerations do we make when it comes to public safety? I mean, air, sea, land. Can you kind of give us a little overview of that?
Yes, and that's the FAA's charter, is to ensure public safety, or the safety of the non-participants, maybe is a better way to describe it. It's in nobody's interest to have anybody injured or killed from a space launch operation or a reentry operation, for that matter. And so far, FAA has been 100% successful. There have been no injuries from space launch mishaps. And that's not only on the ground, that is at sea also, and in the air. FAA does issue notices to airmen and mariners that a launch operation will be taking place. Airspace will be cordoned off for a particular amount of time to ensure that in the event the launch vehicle fails, nobody at sea or in the air, for that matter, is injured. So they're very proud of that they have a 100% record on that. And there's a lot of science or a lot of math that goes into that. Assuming if the vehicle fails at this phase of flight, it failed somehow, whether on its own or because of the flight termination system destroying it. Debris is generated, that debris falls to the ground. How many casualties would be expected from that? So that is one of the major things, that casualty expectation analysis is one of the major things that FAA cares about in ensuring public safety.
And is that's incorporated into licensing, doing those studies like that?
And I'm sure Nick can address this about what the launch providers have to provide to the regulatory agencies for them to get, to ensure public safety.
Yeah, Nick.
Yeah, absolutely. I mean, the flight safety analysis piece is a very bespoke but hefty piece of work that gets done for every launch operation. And they're one of the teams here at Rocket Lab that our teams have the pleasure of working with very closely, as you might imagine. And so they produce they do a lot of analysis as far out as sort of 3 or 4 months before a mission, sometimes longer, depending on the complexity of the mission, to start analyzing if this goes wrong at and it's more granular than every second of the flight, to be perfectly honest. What happens? Where do the engine components end up? Where do the carbon composite structures end up? What happens to them? How do they rupture? And to be honest, we're constantly iterating and making those models better as we better understand the vehicle, as we read other academic research papers, for example, as FAA themselves roll out sort of mandated changes to the way that flight safety analysis is done. And look, the folks that work in the flight safety analysis team here at Rocket Lab, man, like it's an incredible opportunity to work with people like this. I often say that, dealing with those guys, I feel like Penny on The Big Bang Theory. If you've ever watched that, you've got all the really smart people in the room, and I'm sort of sitting there going, wow, I should have tried harder at school. And so the point I'm trying to make here is that, there are some very smart people that's what they do every day, constantly iterating. And the purpose of all of that is to make sure, as Rob said, that in the event something goes wrong, the public or the non-participants are not affected in an adverse way, because that's not good for business. But actually, more than that, as I walked into work this morning, through our reception and just past mission control, it says we go to space to make life better on Earth. And so part of, that highlights to me, Rocket Lab, we take our moral and ethical responsibilities seriously, and part of that is making sure that our spacefaring or space-going operations don't adversely affect the public. And so, flight safety analysis piece is a really big chunk of work, and we invest a lot into making that the best it can be.
Yeah, I think if I had to think for 3 or 4 months about every time I got into my car, how it might blow up and where my body pieces might end up, I probably wouldn't get in my car.
Yeah, no, it's a pretty thorough process, and like I said, we're constantly iterating. In fact, we've got a license modification request in with the FAA at the moment, and we're working really constructively with the FAA on how we can be using sort of real live wins as close to real time for launch as possible, to even better inform the debris dispersion, etc., at launch. And that's not to say that what we're doing right now is unsafe or is not sort of high fidelity, but there's both safety benefits to getting as real time as we can, but there's also operational benefits as well. We can better target where we have boats on the range surveying the range, for example, or open and close airspace in a much more agile fashion, which means that we're upsetting the airlines less, which means they're less likely to go and complain to the government that Rocket Lab's firing all these rockets through their airspace and them to fly around unnecessarily. And so it all kind of works in together, right?
Yeah, it's interesting. Just thinking about how the public can be disrupted by more and more launches, right? So airplanes have to go around, boats can't go into certain areas. I mean, even tourism, beach closures and tourism is affected. Rob, do you want to maybe comment on either maybe what they do in Florida, or what have you seen with other kind of private spaceports that maybe are not located on the coast? What can you say about that?
Florida is a good example. Obviously, the Eastern Seaboard air travel routes going up and down the coast. Everybody wants to go vacation to Florida for the winter. People want to go north, visit family. Very heavily traveled air route. As Nick intimated, that those airspaces are segregated during operations, and you don't want to have to do that for as long or as frequently as the uninvolved public would be impacted. Back in the early days, back when space launch from Florida was, once a month kind of a thing, and it was generally government launches, that kind of thing, the public could get used to that. It's for the greater good. There's a national security spacecraft going up. There's some other government need. Okay, everybody can make peace with that. When launches are happening, 2 times a week, and the vast majority of them now are commercial launches. It is tough to get people okay, there's an hour flight delay because airspace is closed because we can't fly from Newark to Miami. That is harder to get people to agree to when it is a company doing something to earn money. It's like, well, I'm going down there for a business meeting. I need to earn money too. So there's these conflicting equities involved with this. For this reason, FAA has started to roll out means to limit or shorten the amount of time and amount of space that the national airspace would be impacted, pumping data directly from the launch operators into the FAA air traffic control system so that the actual air traffic controllers know when, okay, the vehicle has launched, we can now release that airspace. Whereas previously, back in the days of fax machines, right? They'd have a piece of paper that would tell them from this time to this time, this 10, geez, I don't even know how big they are, hundreds of square miles would be impacted. So that kind of thing, we're taking advantage of technology for that. And FAA that's called the Space Data Integrator, I believe is the name of that. Nick probably knows better. He's probably impacted by this much more than my knowledge. So taking advantage of those technologies. Nick mentioned taking advantage of day of launch winds. Now we know the wind is out of the south. So we know the debris is going to end up in this direction. Whereas when you're doing that global analysis, you have to assume 90 percentile winds from any point of the compass. It's conservative, yes. It is safe, yes. But if we know where the wind is really coming from, it can be as safe by using the real winds. So that technology advancement is really I think it's helping safety because everybody wants safety. But if we can be safe while still allowing other users of the national airspace to use it for their purposes, that's all in the direction of goodness.
Yeah, I agree, Rob. I'd even argue that some of these approaches are more safe, right? Because you have the same range safety team, for example, and as opposed to surveying say a marine hazard area, for example, to keep boats out of what you might have determined using, say, average winds or seasonal winds 30 days in advance of launch, which creates this huge, very conservative, as you say, hazard area. You can look at the take day of launch winds, for example. You can reduce that by, we've seen internally running this in the background as trial as much as 90% of the range. So you're down to 10% of the area with the same range safety team. And so it's much harder to miss a boat when you're looking at a much smaller area with the same range safety team, right? And the same assets. And as you say, the effect on the public is much less. We are working with the FAA right now on the space data integrator process out of Wallops initially, which is great. And the airlines are really on board with it. And as an ex-airline CEO myself, I can tell you the margins are slim. And so anything we can do to share the airspace responsibly and not upset the airlines is actually only beneficial for us as well, right? Because we have to be responsible stewards of the resources and assets we have access to as well and that we share with the public. So everything's tracking in a good direction and we're glad to be part of that.
Can you imagine the fax machines waiting for the fax to come through would be time consuming if the wind may have changed by then.
Absolutely. Well, and we touched on Launch Complex 1 here in New Zealand. And I will say, one of the big advantages is the low population density down here, and certainly the low or the air traffic, especially that part of the country. There's one airline that flies out to one of the more remote islands of New Zealand. It's quite New Zealand's quite a small place, and so we're on sort of first name basis with the CEO, the GM, the ops manager, the chief pilot at that airline, so we can literally call them on the phone and kind of do that consultation with them real time, which is really helpful. And there's things like the medical, the aeromedical flights that we would just hold a launch for if they needed to get through, obviously. But in terms of the big airline stuff, there's, I think, one Christchurch to San Francisco flight that's started up recently. I'm not even sure if that's every day of the week. That kind of goes past the edge of the range. that's what we're dealing with down here in New Zealand, which allows us to be incredibly flexible in terms of launch opportunities. We really don't affect that much air traffic down here. Kiwis love getting out on the boat fishing, so the marine hazard area for us is the one that, you know, the range surveillance team really do work hard on launch day. People are out there trying to get the crayfish and the fish, but you know, again, comparatively to a lot of the places you're talking about and that we operate out of in the States, we have far less of an impact on the public down here in New Zealand, which is what makes it such a great spaceport and why customers love coming down here.
Yeah, that's quite the opposite of Florida, right? That's very high population density and lots of air traffic, lots of marine traffic. Yeah. And Rob, I know that I was listening to a panel discussion a couple of weeks ago about spaceport, private spaceport development, and one of the questions they talked about was tourism and how part of, you know, building or developing private spaceports is also considering tourism. Of course, I think about going to Florida, people watching, you know, the launches there. We've got the whole NASA center. There's all kinds of space opportunities, but then there's also this infrastructure of other things for tourists to do. So that was one of the things they were talking about. Like, if you want to build a spaceport, you got to have a private spaceport, I should say. You've got to have bleachers for people to watch from.
Mm-hmm.
You've got to have some, like, you know, water parks for the kids to go to. It's really interesting.
Well, it's funny because you know, Port Canaveral at Cape Canaveral is a major cruise terminal. So that kind of thing is you know, is in their DNA there in the Space Coast in Florida. They really know how to the hospitality industry is very big there. I don't think it was the same panel you were talking about. I heard a panel recently talking about developing spaceports. Oh, it was at the FAA conference in February. There were international panelists discussing developing spaceports internationally, and one of them, might have been the Italian on the panel, mentioned that it really is, you need to distinguish what makes your spaceport different. You know, it's a business case kind of thing. If it's just another launch site and it is to inclinations that other people can fly to, what's a business case? Why would anybody want to come to your spaceport? So that kind of thing, especially tourism, and generally the tourism is suborbital, so they're not launching to orbit. It's more of a straight up, straight down kind of a thing. You still reach space, but you don't stay in space. And, you know, it only requires, you know, 1/6 the energy to go up and down versus reaching orbit. So it is easier. The vehicles can be safer because you don't need as much energy to, you don't need to make the vehicle so light that it is at risk of failure. So that kind of thing is a little different. It is still a spaceport, but if it's serving a different market than space launch, you know, space lift, getting things to orbit, that kind of thing. Yeah, bleachers, exactly. What are the friends and family going to do? Well, that person goes and gets their pre-flight briefing 4 hours beforehand to get there, do all their thing. What are the kids going to do, you know, during all that? So that kind of thing, you know, it's a different business case. You know, so spaceports cover a lot of different businesses: the space lifts, space tourism, and you know, commercial hubs, or kind of a tech hub kind of thing involving the space industry is you know, an active area. I was just talking to the folks out in Oklahoma. They're trying to develop, you know, that kind of space economy there, even though their spaceport is not operational yet. You know, having that as a center to crystallize that space economy is very big for them.
Yeah, and just the whole idea of space becoming a family affair, and really, you know, young people and people that maybe wouldn't be exposed to exciting things like that are being exposed, and so the whole value of space and you know, having our moments, getting everyone interested in it. So Nick, we talked about the kind of data integration, about better weather prediction, kind of being able to reduce you know, the area that might be closed off for some period of time, you know, down to 10% of what it was, reducing the amount of time. You know, Rocket Lab is known for being very innovative. So I would be remiss if I didn't ask you about these things. Some things that I've read on your website, you guys have started moving into responsive launch. And so tell us about that. The website said within 24 hours you can turn something around. How does that how does that innovation that you were talking about earlier, how does that plug into this idea of responsive launch? And then maybe Rob, I'll ask you to kind of follow up on how United States launch for responsive needs might weigh into the future of launch in general.
Yeah, no problem. I will do. There's a lot packed into that, so I'll do my
I
best
know,
to
sorry.
walk. No, that's great. I love it. It gets very technical very quickly when you start talking about how launches are licensed in the sort of workflow and process. When we talk responsive launch, we're essentially talking about when the customer says go, we go. We stand up the mission team. We get the vehicle on the pad, fueled into orbit. At the truth of the matter is that in the current kind of world we live in, that the licensing or the processes with the regulator have to occur much further out than 24 hours, and so we have to walk through we talked about this before, the flight. We have to give them the flight safety analysis products, for example, for a specific target orbit, so altitude, inclination, launch azimuth. So the best way I can describe that is, and the technical people out there are going to be screaming at their laptops when I say this, but way oversimplified, it's sort of basically the path that the rocket follows over the ground near the launch site, right? So all of those different parameters change the flight safety analysis products and can drastically change where debris ends up and etc. in the event of an anomaly. That all has to happen obviously more than 24 hours out, because you need some pretty specky computers to be running some of this analysis, for example, and then we have to compile the documents, we have to review them internally, submit them to the regulator. They do their checks. That being said, if there's an orbit that we are licensed to fly to, we're currently flying the Electron launch vehicle, so assuming no major changes to that, and the payload has been approved, because that's a whole other sort of regulatory process. So assuming all that happens, when the customer says go, we can turn around a launch in 24 hours, which I don't know if any or many other operators could do. So that's what we're talking about when we talk about responsive launch today. We also do have the capability to execute on a mission that we've done the analysis for before. In the future, ignoring the kind of regulatory framework, we could go and do that. Now, that's the kind of overall direction that the industry and us are taking, is to move towards what I like to call kind of file and fly. So if you think about it and forgive me, aviation background again, if you think of it in an airline context, you book a ticket to fly from LAX to JFK in New York. That is a well-established flight path, on an aircraft type that's flown it before, by pilots that have flown that route before and been checked off by the airline. It's got pre-approved and published procedures. So as long as the procedures are followed, the aircraft type isn't novel, the aircraft's maintained to standard, etc., and the airline has a certificate to fly, you just fill the can with passengers and bags and off you go. And we're quite a way off that in the space world, but that's the direction we're headed, right? As if your vehicle has flight heritage, there's no major modifications to the vehicle that drastically would affect any of the flight safety considerations. If it's from a launch site to an orbit that you've had approved, or the regulator has approved the system by which you self-approve those orbits, then you fill the rocket or the launch vehicle and you go. And we believe that we actually have a lot of that capability in-house right now, and so we're on this journey with the whole industry really, but primarily the FAA, because we're an FAA licensed launch provider, to head in that direction. And it was going to have to come up eventually, but the move to what we call the Part 450 licensing world is all part of that journey. So the current or legacy regulatory framework for launch, it's old and its bones are creaky, and it's not super fit for purpose anymore. But it's done a great job. And like the wise old man that it is, we should learn some things from it. But it's time for the new generation. And so that's very prescriptive. And when space was really novel, you can understand why it was so prescriptive. But technology's moved on, our understanding's moved on, the frequencies moved on, our agility's moved on, and so the regulatory framework has to move with that. And so, it's pleasing that FAA have rolled out this new, what we call performance-based regulatory framework, which is Part 450. It's new. We're learning. There's some challenges. Associate Administrator Mr. Kelvin Coleman, at the recent CST, Commercial Space Transportation Conference that you mentioned, Rob, in DC that I was at recently, announced a new special sort of aerospace rulemaking committee so that we as an industry can all get together and have our say on how the rollout of this new regulatory framework is going and what we've learned. And I apologize for the long waffly answer there, but there's sort of a lot to unpack there. When you start talking responsive space, I think a lot of the capability exists already. We've kind of just got to unlock it, and then we've got to have the regulatory framework that kind of allows that to happen. And I think the way we do that, and pleasingly the way that FAA and the industry is going, is that we approve the sort of process and the system rather than every single mission specific analysis. So I can't complain for being bored at the moment, that's for sure.
I love that idea of if you make a good checklist, they approve the checklist, not everything on the checklist. They're approving that you understand what you're doing. You've got the technology to make sure to check everything on the list. So, Rob, please comment. Part 450, responsive launch, anything.
Nick hit all the high points. That was good. But Nick's absolutely right. The industry is headed this way. The regulator recognizes that we're headed this way. And FAA, the Office of Commercial Space Transportation there at FAA, they have two mandates, right? It's regulate the industry and encourage, facilitate, promote the industry. So that dual mandate lets them be a great team player with industry because they are chartered. In fact, they're not just allowed to do it, they must do it. They must encourage, facilitate, promote the industry. So in my experiences working with FAA, they do have great relationships with all industry partners, launch providers, spaceport operators, et cetera. FAA does not regulate on-orbit operations, but it's that launch reentry piece. So they recognize that technology is better. The operators have their stuff together. So as Nick said, we're on a journey here, and it is very much a team journey to get there. Recently for Space Force, you probably read about in the papers, the Victus Nox mission, which was a responsive space mission, from notice to launch to on orbit, 27 hours or something like that. It sticks in my head. So industry's headed that way. But as Nick intimated, it's really that regulatory piece is now the long part. It's not the technology part of it, generally. Plenty of smart people involved can solve the technical problems. It is, how do you keep the public safe in this? How has everything been checked adequately? So getting to a place where instead of a 3-month process to evaluate one specific mission, if we can get to a place where the process is good, nothing has changed, et cetera, launch provider, you're good to go. So, I don't think it will ever get to file and fly. And your example of LAX to JFK, because rockets, are inherently less reliable just by their very nature. They are so light and so powerful that the mean time to failure is much less for a rocket than an aircraft, right? The aircraft, as you know from your aviation background, you expect a commercial aircraft to have no failures in the entire service life of the aircraft. It's to that level of reliability. Don't think we'll get there with rockets, because if we incorporate that kind of reliability, they'll never get off the ground. They'll just be too heavy. But not saying we can't move the needle more in that direction.
Right. Well, maybe not in our lifetime, but one day, maybe. Yeah. So yeah, bringing industry into those conversations, and FAA has done a great job. with that. And it's about building trust, really, right? And
Yep.
one accident or one thing gone wrong, that, you know, in terms of public safety, the whole industry would be affected, and the economy behind that. So, yeah.
Yeah, and I want to echo that. You know, I think FAA has done by and large a really great job, and I guess like a lot of organizations around the world right now are, you know, critically resourced. I mean, the world's not exactly, you know, flush with cash right now to just go and, you know, have hundreds and hundreds of analysts. So, you know, I know that the folks there work really, really hard. And one of the things that really pleases me is our ability to have a really open dialogue with them, without ever sort of having that fear of repercussion for just having an open, honest conversation. And so when we come across challenges, regulatory or technical, we are really comfortable picking up the phone to the FAA and saying, "Hey, you guys have a bunch of really smart people in the building as well. This is something that we're walking through at the moment. Let's figure it out to make sure that we can do the things that we want to do as a business operationally, but, you know, keep the public safe as well, and, you know, check the regulatory boxes." And yeah, I think FAA is doing a really great job of being quite responsive and open, and yeah, I want to commend them for that. Long may that continue.
So we've talked about some of the authorizations. We've certainly talked about FAA. What are some other kind of authorizing bodies that are in competition here, or complementary to FAA in terms of licensing for safe launch? Rob, can I start with you to maybe make a comment on that?
Well, there's adjacent agencies, I guess would be the best way to describe it. FAA, AST, Office of Commercial Space Transportation, does have the ultimate responsibility for ensuring public safety. But then, you know, in that penumbra around that, there's of course the EPA for environmental issues, Department of Commerce, space traffic management kind of things.
So once you're up there, right?
Once you're up there, well, also when you're launching, I mean, you don't want to run into something on the way up. So there is collision avoidance is a consideration also. So there are other aspects to this, which as technology advances, we begin to realize more and more that, oh, well, this can potentially become an issue. Regulations were written, you know, umpty years ago, where this kind of thing was not necessarily envisioned. So whose baby is this? Who owns this? So you might hear about uncertainty within at least the U.S. government on who owns what, and who has accountability, who's been authorized to do this, that kind of thing. And frankly, that's just a function of the industry maturing and advancing in advance of getting, you know, the right oversight agencies involved.
Yeah, thank you. Thanks. And so Nick, you know, Rocket Lab is in a unique position because they are located in New Zealand, but with a US FAA licensing permissions with a license. So plus you launch, you know, being a New Zealand company, but you have the Rocket Lab USA, so you're launching from Wallops. This is fascinating to me about the internationalization of space. So can you comment on some of the kind of competing authorizations or complementary, of course, that you might face?
Yeah, absolutely. Well, I mean, I was listening to an interview by our founder and CEO, Mr. Peter Beck, not all that long ago, where he said, you know, we started as a New Zealand company, but we're global from the very beginning. And that was because there was no market here in New Zealand. There was no space industry. You know, at that time, at a stab, we would have been 4.5 million people population, I'm guessing. And so by very nature, we had to be a global company. And it was, you know, after a couple of years after setting up Rocket Lab, you know, it became a US company, essentially listed on the NASDAQ, went public. And so now we're a US company with a New Zealand subsidiary. And I guess I was remiss quite early, actually, by not sort of saying that, you know, launch is part of what we do, and it's a very important part of what we do, but it's part of what we do. We build spacecraft, we operate spacecraft on orbit, we build spacecraft components. We are an end-to-end space company. We can basically do the lot, which puts us in a very unique position. I certainly can't think of any other company that can do that that sort of sweep of activities. And so, we sort of coming back to the question about being international, we deal a lot with the New Zealand Space Agency. And the industry here in New Zealand is young, and so the New Zealand Space Agency as well are on a journey with us, and they work obviously very closely with other regulators like the FAA. In fact, there was a revised sort of agreement or letter of understanding, I forget the term, but it was signed recently at Space Symposium between the ministry here in New Zealand and the FAA, which is great to see. And so we find that in terms of the licensing regime we have to follow to operate out of here, we find sort of consistency in the launch licensing piece. And the reason being is that the New Zealand Space Agency or New Zealand government is willing to fully recognize the FAA launch license that we hold. So that makes that part of the journey pretty straightforward. Where it does get interesting is that on our New Zealand launch license, which basically says you have an FAA launch license, great, we like that. But there are some specific conditions specific to the New Zealand government. And so some of that, to give you an example, is around things like orbital debris mitigation planning. So whilst there's no formal rule in America right now around orbital debris mitigation plans enforced by the FAA, caveat to that, there is a notice of proposed rulemaking out there that says that the FAA want to bring that into a line. So close brackets. So there are certain things we have to do around orbital debris mitigation to satisfy the New Zealand government that we are being responsible stewards of the space environment that we wouldn't do if we were just launching out of Vandy or Wallops, for example. And look, by and large, we're on board with that. Again, I refer you to what it says on the door when you walk in here. We were all about making life, better on Earth, and part of that is not destroying the Earth we're trying to make life better on, right? So, we want to be sustainable, not only commercially but environmentally as well. And so, yeah, there are a couple of nuanced differences, but by and large, the New Zealand government has allowed us to sort of just run with the FAA license process with a couple of small extra conditions.
Yeah, that's a good point, Nick. So when FAA issues licenses, they got a couple of things, right? They're ensuring that the involved public is not harmed. But another one of their responsibilities is ensuring that the treaty interests of the United States are covered. That, there's plenty of international treaties, thou shalt not, or here's the norms that we're going to follow, that kind of thing. FAA also has that responsibility to ensure that the launch doesn't go crossways to those. So I can imagine for New Zealand, I mean, that's their piece. Yes, you have an FAA license, fantastic, but there are other New Zealand sovereign interests that we need to look out for. So there's that piece makes total sense.
Well, and we sort of touched on it before as well, right, about the pace the industry is moving at. I had a very interesting conversation with one of the folks at New Zealand Space Agency recently over a coffee about how payload permits are, or the process for payload permits here. And their request to us is pretty early doors. Once we've signed with a customer, they want to start having the conversation about payload permitting. And the reason being is that a lot of the stuff we're doing is pretty novel. We launched a payload recently that was doing an on-orbit rendezvous with an old rocket body to prove the technology. Let's grab hold of this thing and re-enter it so we don't have rocket bodies floating around in space unnecessarily or sort of longer than they have to be. Now, when you start doing the national interest, where you start having the national interest discussion about, well, launching a piece of technology out of New Zealand that can go and grab hold of something else in space, that has ongoing effects, right? Like from a setting like precedent with policy. And so it's all these little things you don't think about. Or certainly, I didn't necessarily. And we sort of just keep learning as stuff comes up. So, man, the people working in space regulation, I know we're sort of seen as working, we're the commercial guys and they're trying to say no all the time and wave a big stick at us. It's kind of not like that. Everyone's working together, and we have to, because they have to learn as fast, if not faster, than us. So
yeah, it is. It's really about those international partnerships. I think that's going to make space a lot safer. So the launch piece, I've been irresponsible, and we're we're well over our 35 minutes. So I'm going to ask for some final thoughts from each of you, and I'll start with you, Rob, but also Nick, if you want to just comment, I'm going to ask you to comment on some of the naming of these missions from Rocket Lab. But Rob, what are some final thoughts that you want to leave people with in terms of launch safety, and maybe building a culture of safety in general, how that might be plugged into sustainability for long-term use, et cetera?
Yeah, I mean, everyone's interested in a culture of safety. As Nick mentioned, it's in nobody's interest to have somebody hurt or injured with this. And it is international, as we've discussed. So I think everybody's all pulling in the same direction on this. I can't think of a voice out there that is saying we're doing the wrong thing in this direction.
So Nick, what about you? Some final thoughts to leave our audience with?
Yeah, look, well, first of all, thanks for having me on the show, Rob. Great to meet you as well. It's always great to talk about this stuff. What would I say? I think it's really, I heard, actually, I'll leave you with this. I heard Jimmy Carr recently in an interview say, it's amazing how quickly we get used to how awesome our life is. And so, couple of things about that. It's pretty awesome what we do in terms of putting things, in space, and the fact that we can do that with the safety record, and I'm talking about the industry as a whole, not just Rocket Lab, has been pretty impressive. But for those of us that are lucky enough to work in this industry, we should not forget how awesome our life is, that we get to do something so incredible and really have such an impact on the world. It's the hidden infrastructure that we all use. As I heard recently, if the GPS constellation fell over, can you imagine the carnage that would go on in the world? It'd be planes not knowing where to go, flying in circles, and as Pete likes to say, Tinder date wouldn't know where to go to meet you. So we all have a pretty big impact, and it's easy to kind of get granular and technical all the time, but sometimes you just need to step back and think it's pretty cool what we do, and it's pretty cool that we're able to do it so safely.
Amen.
Yeah. Great. Well, thank you guys very much for being here, Nick and Rob. It's been fascinating. It's so fascinating that I lost track of time. So I'll leave our audience with some of the names of this, just because I promised. So Rocket Lab's, some of their mission names are Four of a Kind, The Moon God Awakens, We Love the Nightlife, Baby Come Back. Yeah, so anyway, have fun with that. If you have ideas for what to name Rocket Lab's next mission, you can find Nick on LinkedIn.
Absolutely, I'd say jump on the Rocket Lab X or Twitter feed as well, and let the comms team know. So I do have to run, team, but thank you very, very much for having me on today. I really, really appreciate the opportunity to talk with you guys.
All right, bye.
Bye.
Thank you. To our audience, thank you so much for joining us for our 6-part series on space safety through a global lens. And we certainly cannot talk about space safety without talking about launch. So the value of both government launch and commercial launch is going to inform the future of any sustainable space ecosystem that we're trying to build. We hope you enjoyed the series and today's most recent show. Check out the other shows, from international efforts to stop and clean up debris, to in-space rescue and space weather, and others. You can find all of the in-depth research from the Center for Space Policy and Strategy at csps.aerospace.org. And thank you to James Liggins, our technical director. Until next time.